What comes into your mind when you see this word alcohol? Most people think of alcoholic drinks like spirits or wines. There are so many types of alcoholic drinks. Now, it is interesting to note that all these types of alcoholic drinks only contain one alcohol called ethanol. Ethanol is the only alcohol which humans can drink safely. But you need to understand that it is only safe to drink ethanol if it is in alcoholic beverages. You cannot take ethanol alone. If you take ethanol alone, it can cause death. It is very, very dangerous. Other types of alcohols like methanol causes poisoning if ingested. So when you take methanol, it can cause blindness, even death. So you're not supposed to take methanol. Alcohols are among the most common organic compounds and are very useful in our day-to-day lives. And so, in this online lecture, we're going to talk about the definition of alcohols and the classification of alcohols. Alcohols are organic compounds which contain one or more hydroxy groups attached to a carbon atom of an alkyl group. So by now we know that for us to have an alcohol, we need to have an alkyl group and also the hydroxy group. So if I use this alkyl group, this is called methyl. If I add OH to this alkyl group, I'm going to have an alcohol because this OH group is the functional group for all alcohols. So this particular alcohol is called methanol and it only has one carbon atom. So you can see in this particular alcohol, I have got this part, the alkyl group, and also the OH group. This particular alkyl group is called ethyl. If I add the hydroxy group, which is the functional group of all alcohols, I'm going to turn this into an alcohol. And this is now going to be called ethanol. We'll talk about how to name alcohols later. So this is now an alcohol. So the take-home message here is that any alcohol is going to have an alkyl group and also the hydroxy group. So two things make up an alcohol. If you see something looking like this, you must be able to know that this is not an alcohol. This is a carboxylic acid because of this particular functional group. So for you to have an alcohol, you only need to have the hydroxy group attached to a carbon atom of an alkyl group. So if you see something looking like this, you must know that this is a carboxylic acid and not an alcohol. Now, what about if we have this particular molecule? Can we call this to be an alcohol? So you have benzene like this, 6 carbon atoms. Then you have these pi electrons, which are delocalized. You have pi electrons, 6 pi electrons, and you have a bond between a carbon atom of the aromatic system uh, and the hydroxy group. So when you have something looking like this is not an alcohol. This is called phenol. Phenols are not alcohols. Phenols have unique properties and are not classified as alcohols. So for you to have an alcohol, you only need to have an alkyl group and the OH group. That's all. That's what you need for you to have an alcohol. All right, now let's look at how we can classify alcohols. We have two classifications of alcohols. The first classification is based on the number of hydroxy groups. Let's look at this particular classification. So based on the number of hydroxy groups, we can classify alcohols into three categories. So we can have monohydric alcohols, dihydric alcohols, and trihydric alcohols. A very good example of a monohydric alcohol is methanol. So when you look at methanol, methanol has one hydroxy group. So you only have one hydroxy group, and that's why it's called monohydric alcohol because we only have one hydroxy group. So any alcohol which only has one hydroxy group is going to be classified under this category, monohydric alcohols. Alcohols with two hydroxy groups can be classified under dihydric alcohols. So you can see in this particular example, we have an alcohol which has got two hydroxy group. You have one hydroxy group and also another one. So this type of an alcohol can be classified under dihydric, and you can see that word di meaning two. So any alcohol with two hydroxy group will be classified under dihydric alcohols. Alcohols with three hydroxy groups can be classified under trihydric alcohols. So you can see this particular alcohol, which is glycerol, has got three hydroxy groups. So this can be classified under trihydric alcohols because we have three hydroxy groups. The second way of classifying alcohols is based on the carbon atom attached to the hydroxy group. So based on this classification, we can also have three categories. So we have primary alcohols, secondary alcohols, and also tertiary alcohols. For you to decide if a particular alcohol is primary, secondary, or tertiary, you need to look at the alpha carbon. The alpha carbon is the carbon that is next to a functional group. So in this case, the alpha carbon is this carbon right here. This carbon, you can see it is bonded or it is connected to the functional group, which is the hydroxy group right here. So this carbon is going to tell us whether this particular alcohol is primary or secondary. Okay, so now for you to have primary alcohols, you need to have one alkyl group connected to the alpha carbon. So in this case, you can see this particular symbol represents alkyl groups. So if you have got only one alkyl group bonded to the alpha carbon, then what you have is a primary alcohol. Then this is the symbol for primary alcohols. It's one, then with a degree symbol right there. This particular alcohol is called ethanol. If we look at the alpha carbon of this alcohol, the alpha carbon of this alcohol is right here. This is the alpha carbon. This carbon is bonded to the functional group. So this is going to tell us whether this particular alcohol is primary, secondary, or tertiary. Now, when you look at this alpha carbon, we can see that it is only connected to one carbon atom. So it is only connected to one carbon atom, or in other words, it is connected to only one alkyl group. Therefore, this particular alcohol qualifies to be classified under primary alcohols. This particular alcohol that you see is called propanol, and it also qualifies to be classified under primary alcohols because it only has one carbon atom that is directly attached to the alpha carbon. In this case, the alpha carbon is this carbon right here. We know that the alpha carbon is the carbon that is next to the functional group, or the carbon atom that is directly attached to the functional group. So this is the alpha carbon. Now, if you check here, how many carbon atoms are directly attached to the alpha carbon? We only have one carbon that is directly attached to the alpha carbon, and this particular carbon is this carbon right here. So if you only have one carbon atom that is directly attached to the alpha carbon, then what you have is a primary alcohol. For you to have secondary alcohols, you need to have two alkyl groups attached to the alpha carbon. So we know the alpha carbon is this carbon right here, the carbon which is attached to the functional group. So if you have two alkyl groups, you can see we have two alkyl groups. You have this alkyl group and also this other alkyl group. So if you have two alkyl groups attached to the alpha carbon, then what you have is a secondary alcohol. So this is the symbol for secondary alcohols. You have two, then you also have the degree symbol there. That is the symbol for secondary alcohols. This alcohol is called 2-propanol, and it is a very good example of secondary alcohols. So our alpha carbon is this carbon right here. We know the alpha carbon is the carbon atom that is linked to the functional group. So this alpha carbon is connected to two carbon atoms. So you can see we have this carbon atom. We have a carbon atom right there. We also have another carbon atom right there. So if you have an alpha carbon which is bonded to two carbon atoms, then what you're going to have is going to be a secondary alcohol. Another example of a secondary alcohol is 2-butanol. So we have our alpha carbon right here. Then if we count, we have two carbon atoms that are directly attached to our alpha carbon. So we have this carbon, one. We also have another one, two. So we have two carbon atoms directly attached to the alpha carbon. So this means that this is a secondary alcohol. If you have three alkyl groups directly attached to the alpha carbon, so the alpha carbon is this carbon here. If you have three alkyl groups attached to the alpha carbon, then you're going to have tertiary alcohols. So these alkyl groups can be different or they can be the same. Doesn't matter. As long as you have three alkyl groups attached to the alpha carbon, then what you're going to have is going to be a tertiary alcohol. So this is the symbol for tertiary. So anything that is tertiary will have this symbol. It can be tertiary alkyl halides. Anything that is tertiary is going to have 3 and that degree symbol. 2-methyl-2-propanol is a very good example of tertiary alcohols. Let's understand why this particular alcohol qualifies to be classified under tertiary alcohols. So for us to do that, we need to first of all identify the alpha carbon. The alpha carbon is this carbon right here because it's the carbon atom that is directly attached to the hydroxy group, which is the functional group for all alcohols. So now, we need to count the number of carbon atoms that are directly attached to the alpha carbon. Let's count the one carbon atom here. This carbon is directly attached to the alpha carbon. That is 1, 2, 3. So we have 3 carbon atoms that are directly attached to the alpha carbon. Therefore, this particular alcohol qualifies to be classified under tertiary alcohols.